The Yagi antenna, commonly just called a Yagi, is an elegant piece of RF engineering. Its working principle relies entirely on electromagnetic coupling and wave interference. Unlike some antenna designs where every metal part is directly connected to the feed line, a Yagi works by using a single active element to excite several parasitic, that is unconnected elements around it. A standard Yagi consists of three types of elements mounted on a central boom. The driven element, this is the only part of the antenna actually connected to your transmitter and receiver, usually a half-wave dipole or folded dipole. It radiates the initial RF energy. The reflector, placed behind the driven element, it is typically about 5% longer than the driven element. The directors, placed in front of the driven element, they are typically about 5% shorter than the driven element. A Yagi can have one director or dozens of them. When you transmit, the driven element broadcasts an electromagnetic field. Because the reflector and directors are placed very close, by usually between 0.1 and 0.25 wavelengths away, this field induces RF currents in them. Even though they have no physical coax connecting them to the radio, they begin radiating their own electromagnetic waves. The magic of the Yagi lies in how these re-radiated waves interact with the original wave from the driven element. To get high forward gain, which is exactly what you need when you try to punch a signal through to a low Earth orbit or LEO satellite on a handheld radio, you need the RF energy to cancel out in the back and add up in the front. The Yagi achieves this through precise tuning of element lengths to create phase shifts. The reflector, because it is longer than resonance, it acts like an inductor. This inductive reactance causes the induced current to lag behind the voltage. When it re-radiates the signal, the phase relationship causes the RF waves to cancel each other out in the backward direction, that is destructive interference, and reinforce each other in the forward direction, that is constructive interference. The directors, because they are shorter than resonance, they act like capacitors. This capacitive reactance causes the current to lead the voltage. This specific phase shift reinforces the wave traveling in the forward direction, focusing the beam tighter and narrower the more directors you add. The sum of these interacting fields is a highly directional radiation pattern. Instead of a standard dipole's donut shape that scatters energy everywhere, the Yagi shapes the energy into a focused flashlight beam. Forward gain. The signal is heavily concentrated in one direction. Front to back ratio. Very little energy is wasted going backward, and correspondingly very little noise is picked up from behind the antenna when receiving.